the domain of a function is from the leftmost point till the rightmost point where the function exists. The range is from the lowest y value to the largest y value. That's the reason why a domain is measured on the x-axis and y is measured on the y-axis. Good.
So in that example, it would be something like y equals x squared plus
something. Exactly. Excellent. See, once you understand these graphs from the very beginning, everything will be very easy and a smooth ride. Good. Can anyone identify the domain and range? Now, this is not very nice, but they are giving us the function. So they are not giving us the arrows. It goes on forever. The function goes on forever. 8x to the third will go on forever. Can anyone identify the domain and range for this function?
Infinity both ways.
Yes. For this function, both are negative infinity to infinity, the domain and range. Although it looks very skinny, however, this function exists. It's a polynomial function. Polynomial functions exist on negative infinity to infinity. And if you see, it goes on forever. So both.
Will the domain always be negative infinity to infinity?
Polynomials, yes. Let's write that down. It's a very good idea to have in writing. Polynomial functions are always defined, we say, everywhere. By everywhere, we mean this. Oh, I'm sorry. Polynomial functions are always defined everywhere. By everywhere, we mean negative infinity to infinity. The range may not be negative infinity to infinity. So here's a polynomial function. What is the range of this function? Negative x squared.
Function. Well, the domain is the same.
Yes, all real numbers. But the range of this green function is?
Negative infinity.
Negative infinity till?
0.
That's it.
Oh, 0.
What about the domain of this one?
That's the domain is also infinity.
Yes, negative infinity. What about the range?
Range is so that's negative infinity to 13.
That's it. So the range may or may not be all real numbers for polynomials, but the domain will always be everything. Okay. Okay, this is just an attempt to what? What is the attempt here? I'm glad they didn't say turn the page or something. I mean, what is this? Well, what we have to understand from this is that this is the first point and it goes on forever to the right. Let's identify here the domain and range. The domain starts at the leftmost point and goes to the rightmost point. So I'm going to mimic this graph here. And we're going to read from the graph, not from my graph. So this is basically what it says. So the domain of this function starts at this point, which is the leftmost point, and it goes all the way to infinity. What about the range? Well, the range will start at this point with a bracket and will go all the way to infinity. So this is the range and this is the domain. And now we can read from the graph. Can anyone give us the domain of this function? We cannot read from my graph because I don't have the points.
4 to infinity.
So it is 4 to infinity, I agree, for the domain. Bracket at 4 to infinity. But if this point were an open point, I would have used a parenthesis. But it's a full point. Good. And now can anyone give us the range?
-2 to infinity.
Indeed. Does everyone see that? -2 to infinity. Please don't be shy. We can choose other problems, of course. Any questions?
Yeah, can we do one more?
Oh, yes, of course. Any questions on this one? Any questions here? Okay, so let's take a look. Good.
So a closed dot, like a solid dot, means equal.
Yes, and means bracket.
Means bracket.
Yeah, I think this is a good one. So draw the graph of a relation whose domain is a single real number, but whose range is all real numbers. So let's start here. I know, Sarah, you wanted another domain. I'll find another domain or range in a second.
That's okay.
No, because we can look at this with domain and range. So I want to identify the domain and range for this one. Relations have domain and range. This is a relation, of course. So from the leftmost point, so if this is, so 2, 4, 6, 8, 10. So this is from -2 to 2.
It's like 4.
So the domain is between -2 and 2. Do you all see, -4 and 4, sorry. -4 and 4, do we see that?
Yeah.
And the range also from -4 to 4.
Mm-hmm.
Perfect. Let's look at this one. What is the domain? We know the graph. This is x squared. So what would be the domain?
Infinity.
All real numbers. What about the range? From the lowest y value to the largest y value.
0
To,
infinity?
exactly, with 0 with a bracket.
Okay.
Very good.
0 bracket.
Yep, let's look at this one. What is the domain of this function?
Infinity,
Meaning -infinity, comma, infinity.
right?
What is the range? And
Mhm.
this, the range is only one number, 2, 4, 5.
5.
So for this, for the line y equals 5, domain is all real numbers, but the range is only one number. For only one number, I have to use braces. Or for just two numbers or a finite number of elements, I have to use the braces symbol, not parentheses, brackets, etc.
Why do we gotta use the braces for that?
I only have one number. There is no interval here.
Okay.
The interval means always infinitely many numbers, but here I don't have infinite. I only have one.
Okay.
Good. And let's also look at the last one here. Is this a function or not?
No.
No, by the vertical line test, it's not a function, but that's okay. It's x equals 2. For x equals 2, can anyone give us the domain and range?
Negative infinity to infinity.
Which one?
Domain.
No,
No, it's just 2.
domain is just 2
Oh, yeah,
with
yes.
braces. But yes, you're
With
right for the
braces.
range. Yes, negative
Yeah.
infinity to infinity. Are we okay with domain and range? And finding x and y intercepts. And with a little information we have about graphs of x squared and the absolute value of x.
Yeah, I think I'll be okay with it once I do a little bit of the practice tonight.
Yep, this will be invaluable for you moving forward.
Okay.
When I talk about that, I mean the graphs that we talked about. Invaluable, you'll be ahead of everybody else. Good. Moving on. So this is 7.4 now. I hope you're going to do this work before class on Thursday, and you're going to say, show me this, show me that. I've seen this problem. Good. Match from the list of right word, match from the list of right word that completes each definition below. Some words will be used more than once. Fine, thank you. A function is a correspondence between a first set called
Domain.
good and a second set called
Range.
such that each member of the
Domain.
perfect corresponds to
The range.
Range.
exactly
Oh,
Oh, exactly one member of
exactly.
the
of the range.
range.
Perfect. A relation is a correspondence between a first set called
Domain.
yes and a second called second
Range.
set, of course, is the same, such that each member of the
Domain.
corresponds to at least one member of the range.
Range.
Perfect.
Yeah, that makes sense.
Okay. Is this a relation or a function?
Relation.
Yes, because the bird corresponds to two y values. Does the relation represent a function? No. Very good. Select the list that represents the elements of the domain. Of course, fish, dog, and bird. There is nothing else. That's the domain. Select that represents those elements that represent the range. Of course, only what I see. The fins, legs, and wings. Okay. Good.
That just means hungry.
Determine whether, this is important to understand, determine whether the relation represents a function or not. I'm going to copy -5, 1, 2, 2, 3, -6, and 4, 9. Okay. Here's how we address this issue. This is one way. There are other ways. I'm going to do this. -5 corresponds to 1. 2 corresponds to 2. 3 corresponds to -6. And 4 corresponds to 9. Function or relation?
Function.
Of course. It is a function. Good. Any questions on this? So it's a function. And moving on. What is a domain? So the domain has to be written as -5 in the correct order. -5 and then 2 and then 3 and then 4. In ascending order. So -5 and then 2 and then 3 and then 4. Now it's probably going to ask us for the range. So the range has to be also written in the correct order. -6, 1, 2, and 9. The same thing, same type of problem. Good. Is the graph, this graph, the graph of a function?
Yes.
Yes, by the
Y
Line test.
by the
Really?
vertical line test.
Vertical.
Good.
Why did that graph have pi? Whoa. I'm sorry.
That's okay. Yes, this is a trigonometric function. Okay.
Trigonometric?
Yep.
Trigonometric. That's
Yep. We have 6 and their inverses. 6 functions and their inverses. 12 new functions for you. Determine whether the relation defines a function and give the domain and range. So the domain is clearly just 6 and the range is what you see here. But in order to identify whether this represents a function or not, I have 6 going to -3 and I have 6 going to 2 and I can stop.
It's a relation.
It's not a function, yes. Absolutely not. But the domain is all 6. So remember this, the domain for 1 or 2 or 3, any finite has to use braces. Good? Good. Evaluate the function for the indicated values. We've done this, but I'd like to do more. So we have f of x equals x plus 2 over x squared minus 25, and they want us to find f of -2, f of 4, and f of 5. Perfect. I look at this function and I say, oh, I know. I could never ever evaluate this function for which values of x?
Oh, 25. No, 5.
Careful, it's quadratic, so you have to give me 2 solutions.
-2.
You have to factor. Don't guess, please. You have to factor the denominator.
Oh, 5 and -5.
Indeed. X plus 5 and x minus 5. So right away I'm going to write undefined. You cannot trip me because I know that x can never be 5 or -5. For the other ones, I can determine them. I can determine anything you want, but don't ask me 5 or -5 because I'll say, oops, sorry, I cannot give you a number. So for -2, the numerator is 0 and the denominator, of course, is not 0. It's only 0 for 5 and -5. How much is f of -2? The numerator is 0 over a number. What did we say 0 over a number equals to?
0.
Of course. So this is the x-intercept. -2, 0. -2, 0. That's the point. Good, now I have to plug in 4. Not a problem. Let's plug in 4. F of 4 is 4 plus 2 over 16 minus 25. The top is 6. The denominator is -9. I simplify by 3, -2/3. Can anyone give us the ordered pair that we just determined here? We determined another ordered pair. Which ordered pair is it?
That'd be 4 and -2/3.
Good. Please, let's look at the graphing calculator for a moment. Oh, there is a chat. There is a chat from me. Oh, okay. Good. Okay. So with the graphing calculator, please, in y equals, clear everything. Go back up and punch in this function. You must have parentheses around the top and parentheses around the denominator. X squared minus 25. We've done this a long time ago, and now I want to evaluate. And I have these 3 values, -2, 4, and 5. Second and table, it was -2, yes. -2, 4, and what is going to happen when I put 5 in? It's already there. It's going to scream at me. Okay? You can always check with the graphing calculator, but be very careful how you enter the function, because that can mess you up, and you have all their answers correctly, and then you said oops, and you start changing them. So careful how you enter. Okay. Good. So let's look at this problem. And can anyone identify for us f of 4 and f of 3? First, f of 4. How much?
4.
Indeed. You read from this point, which is 4 comma 4. When x is 4, y is 4. Excellent. Can anyone identify f of 3? When x is 3, y is 8. Do we understand how to read these ordered pairs? Okay. Complete the table, that's fine. You know how to evaluate now. Find the domain. It's a polynomial function. What will you say about the domain? We wrote that note 10 minutes ago.